Okay, I'll try to make this video as short as possible. So now the input power this AC 220 volts. It enter through this our small fuse or line breaker. Then for years on a thermistor, NC thermistor. Now the purpose for this NC thermistor, because the NC thermistor be connected in parallel to this our 5 volts relay. Now the purpose for this NC thermistor is make sure say me the capacitor they no charge quick for reduce the charging time for this for increase the charging time for this capacitor so that the charging current will be small, meaning overcharge quick. So when the system come on and the thermistor go to conduct, so you don't conduct stay can give energy, you go conduct then can get energy for the transformer for here, and then we'll get 5 volts from this 78045 voltage regulator. We could come back now can supply this our relay we could put on the circuit. So this our circuit a basic rectifier circuit where it convert this AC will come into here to DC, and then now this our transformer connected in a push pull mechanism for where this DC 311 volts where the end of here it go like this switch 1 and switch 2 they come on at the same time. So when switch 1 they off, switch 2 they on, when switch 2 they off, switch 1 they on, and so on. So the basic principle for the inverter type welding machine have reduce the size for the transformers. So as we go see the real working principle, and I say this BC4047 where it be our main oscillator chip. It create we from pulses. It oscillate at a frequency of 46.3 kilohertz. So that made the switch and the switch on and off where you go to induce EMF across this transformer, and then we'll get a current of about 100 amperes at the secondary, and then use them for welder use them for our normal stick welding purposes. So this circuit way they've under now the power supply for our 4047 and our IR2112 MOSFET driver them. So this transformer now the enter will get one normal rectifier again after the transformer, and then it gets 78112 where the power IR2112 and our 7805B only for this relay. So the power board our 4047 where they give it our 4047 give it that pulses because we don't configure them for a stable mode. So it flip them up down up down up down so that when switch 1 they on, switch 2 they off. So our gate drive circuit, because the output for the IR2112 they giving at 12 volts, and I'm looking for my small oscilloscope for here to work. It give that 12 volts way is supposed to give them. Then now this our diode for here now for help with discharge the gate quickly. This resistor now our gate resistor, this first resistor for here now 110 ohms, and then this second resistor for here now 47 ohms. Then now we'll even put Zener 9 volts Zener diode so that this 9 volts Zener diode now for protect from gate surges. Let me see when the gate circuit of like when it gets voltage spike then for the gate circuit now the man go clamp and down this our Zener diode will clamp that over voltage way sometimes straight impedance figure for gate circuit. So the same thing for this two, and I use two IR212 because I don't try to bias the high side driving, but you know the work. So I use the two side, the high side and the low side. I use two. I use only the low side driver to flip the circuit. Now I don't visualize this waveform and this other waveform on an oscilloscope. It's working very well. We're having 46.3 kilohertz frequency, and the maximum voltage will come up here and 9 volts. You know, I'll be very sure about the circuit. Yes. So the next thing we are going to check again. Now I don't know because the man at 311 volts um and that transistor will be rated 600 volts, because if it be saying an avalanche breakdown. So I'll be very sure say like now the basic working of the circuit is